video. Accidentally press stop. I should press pause. So this is now our piece. You can look up here real quick if you need to pause the video. That's how we came up with those pieces. Probably should check out last year's video actually. All right. So we have 2 pi times the integral from a to b of x f of x dx. Now that's about the y-axis if you're rotation. And that's a general formula that we could use. It doesn't work for every situation. The radius will change. Sometimes it's in terms of y, but I think that is a pretty good picture of what we want. Okay. It's got to be y then, and determining our radius is kind of a trick. Yes, without a doubt. Without a doubt. Okay, we flip it over. We're going to have 3 problems today. We start with 2x squared minus x to the third. What kind of shape does that make? Makes not a parabola, but a cubic. And you can see that if I factor out the x squared, I get 2 minus x. You can see that I have a double root at 0, and it passes through 2. So this function will look a double root at 0 and passes through 2. So I just kind of drew the part that's in the first quadrant. This says it's also bounded by y equals 0, which is the x-axis. So I want to take that region, and I'm going to rotate it, it says, about the y-axis. So I come up with a shape just about identical to what I did in our notes. The problem is I can't use the washer method. Why can't I use the washer method? Because you have the same function determining the inside and the outside radius. So therefore, what I will do is I will draw a vertical rectangle, and I will rotate that around. And when I rotate around my vertical rectangle, I get a cylindrical shell. All I need is one object that I can find the volume of, and then I can do an infinite number of them. Let me unravel that. What is the width of that rectangle? Dx. What is the height of the rectangle? The function, which is 2x squared minus x to the third. I'm going to pick an x value at which I will evaluate the height. I'm rotating it around 0. I want to find the distance between x and 0. I take right minus left, and I get x. So therefore, the radius is x, so this dimension is 2 pi x. No. I find this number right here, this value, which is x, and I look at the rotation for the axis, and I subtract the values. Because this is circumference, which is 2 pi r. So 2 pi r, I inserted the x for r because that's the radius. Yeah, so it could be x minus 2, it could be 3 minus x, it could be all sorts of things. 2 pi times the quantity, say, x minus 2. And that will be our example for number 2. All right, here we go. So this is our shape. So therefore, the volume of this shape is 2 pi x times 2x squared minus x to the third dx. I would like to do an infinite number. In order to determine my bounds, I look at my original area, 0 to 2. Whoop, I put the integral in the wrong spot. I did that last hour. Yeah. Okay, so sorry, I had the x on the outside of the integral. I should have done that. I'm going to distribute my x through, and I get 2 pi times the integral from 0 to 2 of x to the third minus x to the fourth. Oh, I forgot the 2. Gosh! All right, there we go. I look at the original area, and the original area is bounded from 0 to 2. Yep. Okay. So we take the antiderivative. What's the antiderivative? 2x to the third. 2x to the fourth over 4, so x to the fourth over 2, right? But x to the fourth over 2, and then antiderivative x to the fourth would be x to the fifth over 5. We integrate 0 to 2. I plug in 2. 2 to the fourth is 16 over 2 is 8. So 2 pi times 8 minus, I plug in 2 to the fifth is 32 over 5. So 2 pi times 40 over 5 minus 32 over 5 gives me 8 over 5 for a result of 16 pi over 5. Okay, we'll change it up. You see one example of where you use the washer or the cylindrical shell method. Look at a different example that still requires this, but we're going to have a different revolution. So instead of revolving around the y-axis, what do we revolve this one around? X equals 2. That will change our problem. What does the graph of x minus x squared look like? It's a parabola. It is upside down. The parabola travels through, as I factor it, 0 and 1. I'm going to take that area, and I will revolve it around x equals 2. I'll get that shape over there. Anybody have any issue with that? Do you understand why I can't use the washer method? The inside radius would be the same as the outside radius because the same function determines those. So you have to just be able to see that if you sliced it like that, you would have an inside radius that is formed by f of x and an outside radius that is formed of f of x. And so therefore, you cannot use the washer method. That's what you have to be able to see. So instead what I do is I take a rectangle. If it was reflected over this, it wouldn't work either. It all goes back to this drawing. That if you see that washer, the inside is determined by f of x, and the outside is determined by f of x. And so if that happens, you can't use the washer method. All right. So I take that rectangle, I rotate it around x equals 2. I get that. It's a cylindrical shell. I would like to unravel my shell. I get that. What is its width? Dx. same as the width of the original rectangle. What is the height? F of x, which is x minus x squared. The length, I use a formula for 2 pi r, circumference. 2 pi, I have to multiply that by r. Let's think about r for a second. R is the distance from 2 to my x value that I'm evaluating my height. I take my right minus my left. I get 2 minus x. So now I compute my entire volume of this shape. Get 2 pi times 2 minus x times x minus x squared dx. I will integrate. What are my bounds of integration? Why is it 0 to 1? You look at your original area that's bounded. I will start making rectangles here. I'll end making rectangles there. So we go from 0 to 1. You do right minus left. Look at this problem. Right minus left, x minus 0. Right minus left, 2 minus x. That's how we determine distance. Right minus left. Okay. I multiply this out. 2 times x, 2x. I'll try to combine these together. I have a negative x squared and a negative 2x squared makes negative 3x squared. I have negative x times negative x squared. Positive x to the third dx. I integrate from 0 to 1. Okay. What is the antiderivative of 2x? X squared. Antiderivative of 3x squared. And antiderivative of x to the third. I plug in 1. Everybody see that the 1 will cancel with the first 2? 5 times 1 over 4 is? And this year when I'm teaching trig, pi over 2 is it's a value I really like. It just happens to be equal to if you remember. Oh. Arc sine of 1. Oh, I would be so happy if you wrote arc sine of 1. I'd be so proud of you. The sine of pi over 2 is 1, so arc sine of 1 is pi over 2. All right, we flip. All right, last one. Find the volume of the area bounded by y equals x squared and y equals x revolved around the x-axis. What's different about this problem? X-axis. What does y equals x squared look like? Parabola. And y equals x? All lines are straight. Okay. Can we first just get this out of the way? The intersection of these two. We want to take a guess. 0, 0, and 1, 1. If you want to see that confirmed algebraically, you would set the functions equal to each other and you would be able to see that. Okay? sometimes just a good guess works out. Okay. This isn't that tough, just x squared is equal to x, so x squared minus x equal to 0, so x times x minus 1. But you've seen other situations before, it's more difficult to come up with that. So. All right, so we have that. It looks like we're going to revolve it around the x-axis. What's that? Yes. So I revolve it like that. And since I'm going to do a rotation around the x-axis this time. Oh, sorry. Thank you. So as I rotate this around the x-axis, instead of drawing a vertical rectangle, I'll have to draw a horizontal rectangle. Washer method? It would. So some people might say, well, I'll always do the washer method. Go ahead. Can I tell you what I don't like about the washer method? You gotta square stuff. Sometimes squaring stuff is a pain in the butt, isn't it? That's why I love cylindrical shells. You could use washer method on this one as well. Yep. So, as I rotate this around, I'm going to choose to use the cylindrical shell method. I will unravel it. What is the width? dy. So everybody agree that I am choosing some y value at which I will evaluate that distance. Okay. So this is y equals 0 for my axis of rotation. So therefore, what is the distance between those two? Y. So therefore, this long length right there will be 2 pi y. We're going to do the right minus left here in just a second. Yep, it's the, that circumference, the length of the label. But now we have this part right here, this dimension we have to figure out. And that would be the distance between these two functions, correct? But I have to be using the variable what in my representation? I have to use the variable y. So right now, this is y is equal to x squared. I can't write it as y equals x squared. How do I write it? X equals the root of y. And this one's easy, just x equals y, just switch it around. So as I look at that length, I again have to do right minus left, and I come up with root of y minus y. So I will multiply all those together in order to get the volume of that one piece with 2 pi y to the root of y minus y dy, or 2 pi times, this is y to the 1/2 times y is y to the 3/2 minus y squared dy. Now integrate. Should my bounds of integration be x values or y values? It should be y values. I'm going to start integrating down here and stop integrating up there. What are the y values for my bounds of integration? 1. I distributed my y through. Y times y to the 1/2 is y to the 3/2. Y times y is y squared. those are bounds. So how did I find the bounds? I'm starting. So again, we had a thickness of dy, correct? So I look at my original area, and where do I start collecting those area rectangles? I start down here at 0, and I go all the way up here to a y value of, it ends up being 1, from 0 to 1. Because the thickness of your original rectangle was dy. Because I had vertical thickness as opposed to horizontal thickness. No. If you had this, and you use the washer method, then you would have a thickness of dx, right? It depends on the type of triangle or rectangle that you draw. I drew a horizontal rectangle. A horizontal rectangle has vertical thickness of dy. Yes. 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 Y minus 0. 0 is my axis of rotation. Okay, we integrate. 2 pi, antiderivative of y to the 3 halves, y to the 5 halves over 5 halves, or times 2/5, minus y to the third over 3. Fortunately, I'm evaluating at 0. For 0, I get 0. So I have 2 over 5 minus 1 over 3. Or, as I find common denominators, I have 6/15 minus 5/15 for 1/15 multiplied by 2 pi. 2 pi over 15 is the exact volume determined calculation. I love cylindrical shells. I think that they're more useful than the washers in many circumstances. You need to know how to do all of them. You have lots of work time coming up, folks, but that doesn't make the information easy. Be ready to ask questions the next few days. Your assignment is right here.